Hello, everybody. You're welcome once again. Thank you for joining. This is the machine learning basic model. This is good. This is the first class, and like we all know, this is a recap class. So you must have gone through the contents on the learning platform, and then we'll be doing some recap and Q&A session. All right, so let's get started. It's been an amazing 5 weeks journey. This is the 6th week of the boot camp, and I believe that you all have been learning a great deal. Okay, so today we'll be looking at the basics of machine learning. So we'll be doing introductions. We have like 4 recap sessions. So this class will be more on introductions. Then the next class we'll be diving right into all the revisions that we'll be doing. So machine learning is a very broad field. There are a lot of things to learn. And the approach of this bootcamp is project-based. And once you're able to pay attention to all the basics of all the basics in the curriculum for this bootcamp, you'll be on the right path to, growing your career in machine learning. And as a reminder, you should have gone through the Python for data science module before you attend this bootcamp, because it's like a building block of what we'll did in Python. So, and when you're doing machine learning, you should have background of either Python or R or some other analytical languages, because you'll be using that a lot in this model. But for this model, we are focusing on machine learning with Python. So we'll be doing some basic machine learning. We'll be doing a lot of basic machine learning models with Python. All right, let's get started. If you have questions, you can drop your questions. We'll take that during the Q&A session. Okay, quickly, I'll just go through the curriculum for this bootcamp. We're going to be covering supervised learning, classification and regression. I'll be explaining what all that means in class and subsequent classes. All right, but I just want to show you what we'll be covering, and then we'll be doing some feature selection algorithms, and if time permits, we can do unsupervised learning. Because of time, we might not be able to cover all the basics of machine learning, except if we are, this is just like an intro to machine learning. In if you're in a full machine learning bootcamp, we'll be looking at different aspects of machine learning, you know, classification, regression, reinforcement learning, unsupervised learning, and so many other algorithms. But because of the scope of this bootcamp, it's more like taking you through a journey. We've learned Python, we've learned how to do analytics with Power BI, and now we are going into the predictive dimension of analysis using machine learning. All right, so today we'll be doing a recap on the machine learning introductions, and then we'll be looking at regression problems. All right, machine learning. So what is machine learning? In the journey of data analysis, data science, if you remember during the Power BI class, I was explaining the different type of analysis. I talked about the predictive, the descriptive, and so many types of analysis. But in machine learning, you're taking your analysis to the next level. You're doing beyond just the data analyst job, but now you're doing more of predictive modeling. So I want to break it down for you. All right. So machine learning is an aspect of artificial intelligence. I'm sure we might have all heard of artificial intelligence. All right. It's just a subset of machine learning. I mean, artificial intelligence, and it's one of the most widely utilized fields in technology today. You know, all the hype around GPTs, chat GPT, large language models, and all of that, all of them came from artificial intelligence, machine learning, all right? And it's a subset of artificial intelligence. And what it does is that it involves development of algorithms that enables computers to learn from and make predictions on decisions based on data. You know, when you're doing data analysis, what you're doing most times is that you're trying to do some descriptive analysis, trying to check historical events. What can this data tell me? What story can this data tell me? You know, trying to do some ask questions. You're trying to generate insights when you're doing data analysis. But then when you're doing machine learning, you're going beyond now as telling a story with your data. You are going into more of can my data solve problems for me? Can my data tell me give me like give me solutions when it comes to future events. You know, that's what you're doing in machine learning. So you have some set of data, maybe a large data, historical data, and you're applying some algorithms. You're applying it on those data sets such that the algorithm is learning, it's performing some there's some learning going on the algorithms. And after the learning phase, it's able to come up with a model that would give you predictive, but it could be a predictive model now. You're coming up with a model such that you can use that model to make predictions of future events. So that's what you're doing in machine learning. So it involves the development of algorithms that enables computers to learn from experience. They learn from predictions or decisions made based on data. Now, when you're doing your traditional programming, where you have to just give your computer a set of instructions to perform. Like if you want to build a calculator, for example, you can just you would have written all the code. Your computer is just actually following the instruction. Okay, when you say, okay, if A is equals to 2 and B is equals to 3, then you wrote a program to add A plus B together. So you have given it that code. So the computer is just a dummy following that process, following your algorithm. But then in machine learning this time around, machine learning is having some sort of intelligence whereby you're not doing programming in this case. It has programmed itself based on what it has learned, is now able to carry out some particular function. I'll use another case study. All right. Trying to take time to explain this so that we'll have a background of what we are doing, what we'll be doing, from next class. Okay, so when you're maybe a baby is actually born, the baby is, fresh, doesn't know anything. The baby has to follow some, the baby starts observing the environment, and then it starts picking, starts growing. As it grows, it starts learning. And when this baby starts learning, for example, when the baby is learning wants to learn to walk, it crawls first, and then it starts holding up things before it starts working. All right. So the baby must have gone through a learning process such that after a while, you don't have to teach the baby to walk anymore, because the baby is already he has already learned the process of walking. Okay, so when you're doing a machine learning as well, the first time you're training your data is still learning. It's there's a learning phase that happens during the process of you building a model. As you train your data, as you retrain, the data begins to learn some sort of patterns and relationships, and eventually the uh the algorithm or the model becomes very, very good at what you've actually designed it to do. All right, let's move on. Enough of all the theoretical basics. Okay, let's just move on. Can you all see my screen? Someone says he cannot see my screen. Oh, okay. Can you also see my screen?
No, I can't see your screen.
Oh, sorry. I didn't know that I wasn't sharing my screen. Then what was I sharing? Okay, can you see my screen now?
Yes, I can.
All right, great. Okay, so I believe we got the explanation. So let's just move on because of time. All right. So machine learning, now the definition, it can be defined as the study and application of algorithms. So there are different definitions for machine learning. All right. But then once you understand the process, defining it will not be a problem. So it's the study and the application of algorithms and statistical model that allows computers to perform tasks without explicit instructions, relying instead of pattern and inference. So it's similar to what I've been saying. You have applications, algorithm, like we'll be looking at a different type of machine learning algorithms during the course of this bootcamp. And you are using all those algorithms to perform a particular task without being explicitly programmed or without giving it specific instructions like you do writing a program or a code. So it relies instead on pattern or an inference. So I'm going to explain some use cases where machine learning is actually very it's widely used. So machine learning is widely applied in several industries. So these days we're in the age of AI, deep learning, large language model, and all of that. But machine learning is still so super relevant. In fact, it's very relevant when it comes to some of our key operations in different industries. For example, the Gmail that you use and the emails you use, you do there we have some sort of classification algorithms happening at the background. So the algorithm that actually helps you to sort for example, if you're using a Gmail, you have your inbox, you have your promotions folder, you have your updates folder. So the algorithms that helps you to sort your emails into when the email comes, automatically it filters it knows the ones to go into the promotions, it knows the ones to go into inbox. It's actually machine learning that is going on at the background. So and then it knows the one to go to spam, where you have a kind of spam email. No, most times you don't even see it in your inbox, it goes to spam. So machine learning is applied in a wide range of application and industries for demand forecasting, for example, in sales, when you want to predict future trends of what your customer would be purchasing, you can use machine learning for that. For inventory management, you don't have to waste time to start stocking up products that people might not need. So you can, as a machine learning engineer, you're able to build a model such that you know what the pattern at which people are buying things, and then you're able to stock up your store based on your customers' purchasing pattern. All right, we talked about in banks, you use it a lot. In fact, with the advent of machine learning, you find out that so many of these financial solutions became very good in terms of you see a lot of institutions now can easily give loans and all of that. It's because machine learning had actually gained some ground where they are able to build some robust credit scoring systems where you can easily check a customer's credit score. You don't even need some banks don't even, they don't need collateral so long as they are able to they had already learned, they've built a model that can handle that. They easily give out loans. They know how, the people that have the ability to repay and all of that. So use machine learning for that as well. Targeted marketing. These are just some of the use cases. Adverts, online purchases, when you're purchasing things online. For example, if you're buying something on Amazon, you're browsing, it uses your browse some cookie data to store your browsing history, and then you're able to, by the time you're visiting the site the next time, it's showing you, okay, if someone had bought this, of course, the person is likely to buy something related to that, or probably he has studied what other people that had bought that item um would likely buy, and then it brings it to you to buy, because it knows that people that are actually buying this item are likely going to buy another item related to that. So machine learning is that, and usually most of the time you find out that they are relevant. It's actually relevant to the customer. So we have this all of these use cases, and it's actually very versatile and capable to produce to process vast amount of data. So it's very, very applicable in lots of domains. So as a data scientist, understanding ML is an added advantage to you, or a data analyst. Once you can start pivoting into doing machine learning, doing predictive modeling, doing building models, and then gradually go into deep learning, you have so many advantages. Unlike just doing data analysis. Data analysis, on its own, is actually very good. If you're very good at it, it's a very, very good skill set. But having machine learning on top of it, it's actually a game changer. Now, quickly, enough of all the backgrounds. I want to talk about the data science process, or it could be a ML process. So we have different if you read papers, you have different projections about the data science process. So you can I'm going to just focus on, just I'll go pick one or two. Then there's a video on LMS that you can watch that would help you, that would explain the other processes. All right. So we have the KDD, the knowledge discovery databases. We have the CRIS-DM. We have the big data pipeline. And I'll just explain what this says very quickly. The process of data science, according to CCC 2012, we have the different this data analysis process, or the data science process. The first process is your data acquisition. You're gathering your data. After you've gathered your data, you've done your questionnaires, you have all the data sets that you want. Then you start with your data cleaning process, extraction, cleaning, annotation, depending on what kind of problem you want to solve. So you start doing your data cleaning. So people that did Python for data science model, we did a bit. We did some data cleaning. So that's what you'll be doing at that stage, cleaning the data, preparing it for the model development stage. And then the next stage is the integration, aggregation, or representation. And what you're doing here is that you're trying to put together those data, gather all the related records together, looking for relevant features that will be applicable in your modeling phase. And then at that time, you'll be checking different, things during that process. And then after you're done with that phase, you go to the analysis phase, or the modeling stage, where you have to build your models, and then you interpret your results. And then it's a feedback loop like that. So that's the CCC model. But all of this, the KDD, the Knowledge Discovery Database, is 1996 too. They have like similar processes. But today, you find out that let me just go through the KDD process. It says selection, preprocessing, transformation, data mining, and interpreting of results. So it's almost the same process. For the CRIS DM, we have the business understanding, identifying your project objective, knowing what problem do you want to solve. And usually it follows this pattern. For example, if you want to do a typical data science project, or you want to do something related to building a machine learning or data science projects, the first step is to do your requirement gathering. You have to understand what are my objectives, what problem am I trying to solve. And this forms the type of data set you're going to be collecting. This forms the people that you're going to be interviewing if you'll be gathering your data from scratch. This forms your stakeholders within that particular space. So you have to do your project business understanding, identifying what projects, what problem you're trying to solve, and then afterwards you have to now collect your data. So there are different ways of data gathering. You could use the questionnaire method if you're gathering from scratch. You could do web scraping if you're allowed. In some countries, you can't scrape data from people's website without their permission. All right. So you can do you can collect data from databases if you have working with the company and then you have access to the database. You could get the data from the database department, or you could do focus groups discussion. So we went through some of this during the Python for data science class, talking about the process of we working or solving a data analysis problem. All right, so collect your data, review it. Now, the quality of your data is very key to your machine learning model. So if you're gathering data, you have to be sure that you're gathering quality data. Okay. And quality data in the sense that the data is speaking to what the problem you want to solve. At that data gathering stage, really, you might not really be sure of ticking up all the objective and the hypothesis, but then you're checking that the people that are filling your questionnaire, you're not having like 10 same person filling the same information. You're already gathering redundant data at that stage. You're sure that you're covering a particular sample, when you're doing population sampling. So in machine learning, there are some key things that you need to know. You need to know a bit of statistics, mathematics, and programming. And in the sense that you must know your basics of population, you must know some probability, descriptive statistics, measure of central tendencies, and some of this statistical analysis, because that will help you in analyzing your results. Okay, so you can, like, for example, if I want to do a project related to a school in let me pick a state in Nigeria. I'm in Nigeria, so I'm going to pick a state in Nigeria. For example, in Lagos, I want to do a project related to schools in Lagos. I'm not just going to focus on one school and then I judge based on that. I'm going to do like a random sampling. Like I'll have some KPIs, some things that I actually want to achieve across the schools. Okay. And then I could now focus on private schools, for example, and pick maybe some private schools across different categories, so that my work will be spread across those across that population sample. There's no way you can conduct a research on the entire population, but then you should have a quality sample, so that there will be fairness in your model. When eventually you build your model, you're not going to be building your model for just a particular small niche. You have to have a general sample of your data. All right, so collect and review your data. Then you start your data preparation state. That's the place of you doing the data cleaning, data analysis, checking for missing values, checking for outliers and all of that. We'll be looking at that as we go on in this class. Then we have, after doing your cleaning, your data cleaning, preparations, and all of that, now you're ready for the modeling stage. So at that point, you'd have decided, okay, what model do I want to build? So we'll be going into the machine learning model shortly, algorithms. We have the supervised and the unsupervised learning problems. So you have to understand, what problem am I trying to solve? Is it a supervised learning problem? Is it an unsupervised learning problem? That would guide what model you'll be using for your to solve your problem. All right. So at this point, at this modeling stage, you're choosing your algorithms, you're building your model, you're fitting it, you're then making predictions with your model. After that, you do your model evaluation. You have to evaluate your results. If what you've actually built is correct, and then there is always an iteration. Now, there's this feedback loop where you have between the collecting and reviewing the data and then checking with the project objective. There is a loop going on here. There's a loop here as well, modeling, because when you build your first model, the final model you use at deployment stage, you're looking out for your best model that would scale. Okay, so you have to, do a feedback. You might have to benchmark several kind of models for this purpose. You do your model optimization, you do feature selection, feature scaling, and so many things go on this phase. There's a feedback loop here as well. Then after you're satisfied, you've gotten your model, you evaluate your results, you're good with the model before you pass it on to the developers to deploy the model. Even at the evaluation phase, you're still checking your business objectives, your project objectives. Is it solving the problem I want to that I have at hand? Am I actually doing the right thing? So the data science process is not a joke. You might be on I mean, a model trying to work on a data. When you're working on a live data set, real life data sets, it can take days, even weeks to build a very good model. Okay. And then because of the kind of the large data involved, you might not even have to do it on your system, your local system. You might have to work on the cloud. And that's why you have so many certifications that had to do with cloud, like the Azure, the Google and science certifications and like that. So you have to there's a way to build machine learning models on the cloud. It's different from the way you do it on your local system. Okay, so all of that goes on at the background before you finally deploy your model. When you deploy your model, there is still this loop of you feeding back all the outputs, I mean, inputs from the external user. You still feed it back into your original model just for it to continue that learning phase during when your system is actually live. So that's why you find out that, like I just explained, the baby steps. As the baby is taking its steps, it's falling, it's learning, fully stand, fall, stand, fall, stand. And as his learning rates, gets perfect, it gets to a stage where it doesn't fall anymore. And that's why you find out that like all this for persons that have used maybe some of this GTPs, like large language model application, you find out that it kind of it learns who you are. You can even build a specialized chat bot for yourself, where it knows what kind of questions, based on what you've been feeding it with, the kind of questions you've been asking. There is a learning going on there. So the more you ask it questions, you understand the kind of person you are. You understand what kind of responses that you'll be anticipating. So it's a very interesting process. but then there is a lot of work that goes on at the background. All right, so at this point, do we have any questions before we go into our notebooks? Any questions? Any questions? Okay, so if we don't have any questions, I'm just going to jump right into the notebook that we have for today. So please, we have for you to benefit so much from this session, the past bootcamp recording are available on YouTube under our data science bootcamp playlist. So you can visit the past bootcamp recording and just go through it. The files are on the LMS. They're also linked on the LMS as learning platform as well. Okay, so you can also watch that to further explain some of this concept, because what we'll be doing at the recap, we might not be able to go in depth into some concepts because of our time. All right, Joseph, you have a question. Let us just take your question, please.
Hello, ma. Good evening.
Good evening.
Good evening, everyone. Ma, thank you very much for the session so far. So I just want to chip in. I want to chip in something, and then I think my question will just kind of help the whole house. From what I've gotten so far from what you've discussed, like you made mention of after all the model development and deployment, after that, then you if I get what you said clearly, then you give it out to developers. So does it mean that as a machine learning professional, when you are done with all the data phase, data preparation, pre-processing, model selection, and then deployment and all of that, does it mean that after all that, it is not your job to develop it, or you still need skills after you've gotten all these skills of data pre-processing, data collection, and all of that, then down to model deployment? Do you need an extra skill for you to be able to develop this model to come into play, like to make it come alive? I don't know if you get my question, ma.
All right. Thank you for that question. I understand the question. Okay, so now the question now is will I call it relative, because it depends on what kind of solution you're building. Okay, so if it's just the project, the basic project, maybe something that's related to schoolwork, you might have to do some deployments on your own. And that's why we have like we have some tools like Streamlits that we introduced to you during the Python for data science module. So there are some applications that once you understand how to code in Python, you might not be like Streamlit supports the use of deploying your models on whatever interface. Maybe you want to have a user interface or somebody interact with it. So you can use Streamlit to do that. It's simulates. You don't have to start writing all the HTML, the CSS, and all of that on your own. So long as you know how to do some, you know how to use the packages, the Python packages, it's easy to deploy your application on Streamlit. Or otherwise, you might have to, use some Python framework like Django, Flask, and some of them if you're using Python. with CSS and all of that to deploy your application. That is in a case where it's your personal project. Now, if you're working in an organization, so it depends on what you're employed to do. Within an organization, usually in a standard organization, you have the technical department, like the research R&D, where you have the data scientists, the data analyst. You might not even be the one doing the data analysis. Some person might have done the analysis of the data. And then as a machine learning engineer, you're focused on more on researching models, because this model development is not there are a lot of work that go on the ground. You don't want to deploy a model that would fail in production. And if it's a model that is predicting whether someone is going, maybe in the medical space, that you're building a model that predicts whether a patient has cancer or not, that kind of model has to be very, very, because you don't want false positives. We'll get to that during the course of the program. So there are some models that are so costly that can cost people's life and money. So you have to do a lot of research in your model development phase, the kind of algorithms to use, how to improve performance, be sure that what you're doing, all the steps are, they are in a proper order. So you have a lot of work to do as a machine learning engineer. In some of those, or some organizations, like you have a separate dev departments that does the development of the applications for them. So the developers, those are the software developers that they into the front end, the back. Just like in an organization, you can have a UI UX, that's the user interface, user experience people, and then you have the people that do the front end, you have people that do so it's like that. You have the data scientists separately that do all the modeling and all of that for you, for the company rather. And then once they are done with their work, they've tested it, they push out a batch, and then it's working fine, then they can now, maybe there are different ways to push your project to production. You can save it as a pickle, you give them the pickle file, then they integrate it into wherever platform they want to integrate. Maybe it's on their mobile app or on the web application, So it depends on where you are actually using your model, the kind of organization you're working with, what your job is required to do. Like there are some organization that you will be employed as both the data analyst, the data scientist, the machine learning engineer, and then you have to develop and push the model to production yourself. So it depends on where you're called to do. But strategically, what's your job actually is, the model, from the data analysis, cleaning, building a machine learning model, then pushing it to production. You might not be doing so much of deployments, except if you're called to do that. You're assigned to do that. So though having the background of programming is a plus, it to be a plus for you, so that you can easily integrate seamlessly into any organization. All right. So I don't know if that answered the question. And is that question answered so that we can move forward?
Yes, ma. Thank you very much. Justified. Thank you, ma.
All right. Okay. So if there are no other questions, we can push the rest for the Q&A session. Let's just get to, I want to explain the different type of machine learning, how problems that we have, the machine learning problems we have. So I've just share the notebook shortly. Okay. Okay, so a lot has been said about what is machine learning, use cases, the data analysis process. Now we're going to get into what are the different machine learning algorithms or models that we have. Just as like as a little recap, I talked about machine learning be allowing you to, it involves you allowing computer automate your task that would have otherwise taken manual efforts to do. And then the algorithm is learning based on learning a particular pattern on your data, and then it improves with experience. Okay, we have the different type of machine learning problems. We have the supervised learning, the unsupervised, and the reinforcement learning. Some people say it's 4, some people say semi-supervised, but then I'll just leave it at 3, because 3 usually is 3. We have the supervised, the unsupervised, and the reinforcement learning. Now I'm going to explain what this means. Just try to follow me. For the supervised learning, as its name is, you are supervising the learning of that model. And what do I mean? What I mean is that in machine learning, what you're basically doing, you have a set of data, historical data, and you have some models that had already been built or written. You want to use that model to learn a particular pattern on those historical data, such that they're able to, as they learn on their own, they can make good judgment or predictions for future data set that they've not seen before. For example, you're building a model that would predict whether it's going to rain or not. Maybe a model around temperature, okay, or rather rainfall. And then what happens is that you'd have gathered some data related to weather, some climate weather related data, and then you'd have built a model, used applied some machine learning models on that data, such that it builds you a particular model that for future data sets, it tells you whether it's going to rain or not. So it has learned a relationship that, okay, on maybe in year 2023 January, it rained on this day, it did not rain on that day, and then it's creating that learning pattern such that for future data, it's able to tell you with some certain level of accuracy that it's going to rain or not. So when you're doing that, you're doing a supervised learning. It's a supervised learning problem that you're solving. All right. So in supervised learning, we have the classification problems and the regression problems. So I'll be explaining what that means as well. For the unsupervised, I just want to give like an overview. Then we'll come back to the supervised learning. So for the unsupervised learning, we have the clustering and the dimensionality reduction. The clustering involves you building a model around recommendation engines, targeted marketing, customer segmentation, models that involves you building something that has to do with grouping some set of people together or based on some certain kind of characteristics. So what you're doing there, it's unsupervised. You don't have maybe a target that you are predicting. You don't have whether you're predicting rainfall or you're predicting weather, or you're predicting price, or you're predicting whether somebody's going to have malaria or not. You don't have a target that you're predicting. So in unsupervised learning, you're actually doing some sort of clustering. You are giving the model the entire data, and you're telling it that, okay, can you just learn the relationship between that data? It could be a clustering kind of relationship. You doing some sort of clustering a particular some customers together based on their buying patterns, and it can cluster them into maybe 3 types of customer. We have maybe customers that are low purchasing customer, middle purchasing customer, or depending on the kind of data that you're working with. So when you're doing that, you're doing unsupervised learning. All right. Then we have the reinforcement learning. Reinforcement learning involves you building a model that has to do with it's usually is used mainly in games, where you want to build a model that has to do with rewards, model that has to do with you learning strategies. You use reinforcement learning for that. Maybe you want to build a kind of an AI that would beat somebody in chess games. You can use reinforcement learning for that. So, well, that's beyond the scope of this class. We're going to focus majorly on the supervised learning for this class. So we'll be talking about the classification and the regression. Time permits, we can do the unsupervised learning as well. Okay, so now to the supervised learning. Like I mentioned earlier, it's a type of machine learning task that involves predicting a known label. You know what you want to predict. You have a target variable you want to predict. So I believe everybody that is in this class, you have a background of Python, so to speak, so that we will be on the same page. Like you can do some data analysis with Python, because that is a prerequisite for this class session. All right, so in your data sets, you have your set of rows and columns, and out of probably you have like 10 columns. Out of those number of columns, there could be one particular column that you're trying to make prediction on. For example, in our use case here, we have a salary data set where this is just a single I mean, it's a data set with just 2 columns. So we have just one feature and one label. So you could have data sets with more than 2 columns, where you could have maybe 10 columns being the feature, and then you have the 11th column being the target. So here, what you're doing here is supervised learning, because you're trying to predict a known label. If you are predicting salary in this case, we are doing a supervised learning problem. So now under supervised learning, we have the classification and the regression problems. For the supervised learning, your data set could include number of bedroom, house age, state of population, and all of that, price, etc. So for the regression problems, it's a kind of machine learning task that involves predicting a known label that is a continuous variable. What do I mean? During the Python class, we learned the different type of variables, right? We have the continuous, we have the categorical variable. So the continuous variable has to do with variables that are the numerical type of variable that are floating point numbers, maybe like prices, temperature, something that is continuous, 1, 2, 3, 4, 5, that doesn't have a category. So when you are predicting a label that is a continuous variable, what you're doing there is regression. You have a regression problem at hand. For example, if I want to predict the house prices of the price of a house in a particular region, price, it's a continuous variable, so that's a regression problem. If I want to predict the age of an individual in a particular territory, it's a regression problem. I want to predict temperature. I want to predict loan amounts. I want to predict humidity. I want to predict anything that has to be continuous rate. So you have to understand this, because that will help you apply your models rightly. Okay, so a task that involves predicting a known label that is continuous is a regression problem. And then for regression problems, when you want to solve that kind of problem, you have to use regression algorithms to solve them. And we have some of them, like the linear regression, support vector machines, the decision tree regressors, the random forest regressors, and many more. We have so many of them. Okay, so for the regression problems, you have to use a regression algorithm to solve the problem. Now to classification. For classification problem, you're predicting a known label that have classes. For example, you're building, you want to build a machine learning model that can categorize emails as spam or not spam. So in that case, it's a categorical label you're predicting. You're predicting a categorical label. So that's the classification problem. Another example could be you're predicting species of flower, you're predicting who is going to win an election, you're predicting different, maybe somebody's going to have malaria or not. So many of them like that, classification problems. And for you to solve the classification problem, you have to use the classification algorithms to do that. And we have some of them. We have the logistic regression, the decision tree classifier, random forest, k-nearest neighbor, his support vector. So all of these algorithms where they are actually Python packages, that you can during the Python for data science class, we learned about packages like pandas, numpy. So some of this logistic regression, they are actually packages that have been written by some researchers. A lot of mathematical models are involved and so many, but they've developed it such that you can use that algorithm on your data, and then it's able to make predictions for you based on the kind of problem you're solving. So you can actually go and further your education and develop another machine learning algorithm, as some sort of contribution to knowledge, if you know how to, develop one, and you test it and see if it works, and then you become a master or a doctor in that area. All right. So we have this different type of algorithms based on the problems you're solving. Okay, we've talked about the unsupervised learning. It involves prediction without a known label. Now, when we're talking about the supervised, those are the classification and regression. We said that it involves the prediction of a known label, right? For the classification, for the regression, the known label has to be what? Continuous. For the classification, the known label has to be what? Categorical. For unsupervised learning, it involves a prediction without a known label. You don't have a label. It involves clustering or grouping of features based on certain characteristics. So you I have some algorithms as well that can solve such problems, like the hierarchical clustering, the anomaly detection, k-nearest neighbor, a priori algorithm, k-means clustering, and so many of them as well. The reinforcement learning as well, it's a machine learning method I mentioned before that is based on rewarding desired behavior or punishing undesired ones. Okay, so we are just going to walk through this quickly, and then I'll take questions. We're supposed to do a recap for 1 hour, and then we'll do questions for the remaining hours. So it'll be good for you to kind of watch and read ahead so that I have questions to ask. If not, you'll just be you just won't be maximizing the use of our Q&A sessions. Okay, so if I'll go through the machine learning pipeline, and when I'm done, I'll take questions. And then, okay, I'll do our quiz. Our quiz will not be on Slido today. I'll just ask some questions, and then you can drop the answer in the chat, and we would all agree on the right answer. All right. Okay. So the machine learning pipeline, I discussed it earlier when I was walking you through the different type of data science processes. And but basically, what you're doing when you will have a problem that has to do with machine learning at end, you have to first of all identify the type of problem you want to solve. Is it a supervised learning problem? Is it a non-supervised? Is it reinforcement learning? If it's a supervised learning problem, what type of supervised learning problem is it? Is it regressional classification? So all those things has to be settled if you want to build your machine learning model. Afterwards, your design, I mean, that's when you're setting your objective. You do your project objective, you do get data gathering, you have some hypotheses you want to test. Okay. At the gates data gathering phase, you could do through surveys, complete database. So we've gone through this. Then you do your data pre-processing, you clean your data using pandas, or you can use Excel, right? You can deal with missing values, remove duplicates, remove outliers. Then you do your data analysis by checking doing some visualization with. So all of those things we've learned, they actually come together when you want to build your machine learning model. So you do your exploratory data analysis by doing your checking the information about the data set, use the describe function for summary statistics, and all of this process, goes into that. Then you come to your model development stage where choose your machine learning. Now, if you establish that, oh, it's a supervised learning problem I want to solve. Now I have to start looking at my supervised learning algorithms like linear regression, the linear regression model, you have the SVMs, you have your decision tree regressor, and so many of those algorithms. And afterwards, you choose the one that you want to use. Then at the model development stage, we'll be doing the practicals from next class. The first step is importing your algorithm. After that, you separate your data into your X, you select your features, that is the features, you specify which one are the features, and then which one what is my target. After separating your data set into your features and your target or label, then you split your data set into the training test and test set. So there's something called, we have the train test splits and cross validation. So what you do at that time is, because you don't want to build your model on the entire data set. You want, for example, you have a data set that's about 10,000 rows. I want to build a model that would predict probably temperature. Okay. You won't give your model, that's, for example, and you have chosen that I want to use, I'm predicting temperature. So which type of model am I going to use now? I'm going to use a regression model because that's a regression problem. So I'm going to choose something like a linear regression, or I can choose something like the naive Bayes, any of the regression algorithms. Then I won't give my model all the 10,000 rows. I would have to keep some so that I can use it to test whether the result of my model is actually, my model is actually performing well or not. So I'm going to split them into training tests. I'm going to use probably like 80% of the data to train my model, and maybe 20% to test it if it's actually working well or not. So we'll be sharing, I'll be showing you that using examples from next class. So you use your train test split to do that, or cross-validation. Now it goes beyond just splitting it into two sets. Cross-validation is that you take the first step. You can split it into even more than maybe like 5 steps, depending on the number of steps you choose. You split it into the first step. I would have to explain using an example so that you get it clearly. So let us just leave that for now. Let me move forward. So after splitting your data, you have your training test set and your test sets. You instantiate your model. That is, you set your model. You give it a variable. I would also explain that when we are doing implementation. Then you have your fitting phase. You fit your model, your X train with your X train and Y train, and then you make prediction using your test sets. Eventually, you evaluate the performance of your model using the evaluation metrics specific to the kind of model that you're trying to build. Okay, so that's typically the process. So if you have a poor performance, you go back to the step, is either to get more data or to do your feature engineering again by generating new features, or you do data cleaning, or you tune the model hyperparameters, or you use another model. So a lot of work goes on when you're doing your machine learning model. All right, so this is just the basic introduction to machine learning. At this point, I'm going to stop to take questions. And if you have any question, you can just drop your question in the chat. But before, if you're not going to ask question yet, let me ask my own question, and then we can ask our question. First, I want to ask the first question. Can you give examples of regression problem? Okay, let me start with this. The first question. Machine learning. Okay, how many types of machine learning problems? Can you list the types of machine learning problems we have? We talked about 3 today. Can you list them? Okay. Thank you, Kelvin. Okay. Thank you, Adiola. All right, great. Do we all agree to that? I think nobody's having a different view. Okay, so we all said supervised, reinforcement, unsupervised. Great, great, great. Okay, so if I want to, okay, let me give this next question. The next question says that, can you give me an example of a regression problem? A regression problem. An example of a regression problem. Okay, price. Adela says price. Temperature. Okay, rainfall. Humidity. Good. Sales. Weight. Good. Let's keep it coming. Height. Okay. Sounds great. Like we have weather forecasts. Okay. All right. Can you give me an example of a classification problem? Spam email. All right, great. Classification problems. Fraud detection. Fraud in what sense? Now, fraud, it depends on what you're predicting. Is it whether somebody is whether a customer is fraudulent or not, or you're trying to understand the pattern? So fraud detection, you could use that in unsupervised learning. It depends on what you're doing now, the objective of fraud detection. So if you want to predict whether somebody will be fraudulent or not, or for somebody, a customer will be fraudulent or not, okay, that's a classification problem. But if it's something that you don't even know, usually fraud, you don't even know the person doing fraud. So you're giving them a database of account histories or transactions. You're giving the algorithm a full data of different transactions. Then it's going to understand the pattern that of people's transactions. And if it identifies an irregularity, it classifies that customer as a fraudulent customer. So you use that majorly in you use it majorly in unsupervised learning. That's like an unsupervised learning problem. If you want to do fraud detection, anomaly detection, and all of that. Yeah, but yeah, so that's why I said it's kind of tricky. For diseases, yes. If you're predicting some kind of diseases, okay, maybe you have a specific kind of category of disease you want to predict. That's a classification problem. All right. Okay, products categorization. Okay. Given different type of categories within the product. Okay, all right, okay. Age group. All right. Okay, I think we have like a general idea of what the classification problems are like. Okay. Bank identifying to give a loan or not. Okay, great. Yeah. Customer churn, customer attrition, employee attrition in HR. Okay, so those are classification problems. So when you're faced with that, you know that you'll be applying classification algorithms. All right, I think we have a good understanding of what we talked about. Okay, so do we have I'm done with the questions. Do we have any other question? I don't want to ask us questions beyond the scope of what we've discussed so that I don't shake some tables. All right. Okay, so do we have any question? Anne, okay, please go ahead.
Okay, thank you, Grace, for the wonderful presentation. My question is about future selection. Like when I'm selecting my futures to use in the modeling, what criteria could I use to select? Do I use the explanatory data analysis phase I've used so that I see the significant ones and not the significant ones so that I can use those, or there are other ways I can use?
Okay, thank you, Anne, for that question. So for feature selection, it depends on the problem you're solving as well. If time permits, we can, touch on feature selection for some of the data set we'll be working on during this boot camp. But for previous, if you follow the recording of the previous boot camp that are on the LMS, we dealt extensively with feature selection. So in feature selection, when you're building your model, there are algorithms that you can use that can assist you with feature selection. Except when you're doing if you're doing your exploratory data analysis from scratch, that can guide you, to for you to know. For example, if you're doing a regression problem and probably you're predicting price, you can use your correlation matrix, when you're doing your analysis, you're seeing the features that actually are highly correlated with your price targets. And when you're doing that, it kind of guides you on those features that might impact your model, that might be good predictors, right? So that is the one way to go about it. But then there are several other ways. You can use algorithms. There are different feature selection algorithms that you can explore to help you with your feature selection process. Okay, so you can take a look at those videos. I can't start explaining now because it's beyond the scope of today's class, but for subsequent classes, when we're at that stage, I would explain using examples to explain would be very, the best to approach that. So there are algorithms that you can use that would help you to deal with feature selection. I don't know if that answers your question, Han.
It really does. Thank you.
All right, you're welcome. Okay, do we have any other question? All right, so if there are no questions, I want you to take out the remaining time. You can follow the past recording. So the past bootcamp recordings. The reason why we are doing this is that we noticed that there's so many things we needed to cover. So we don't want to go over what we've done before. So that's why we're giving, and then there was no enough time to actually take questions during those sessions. So that's why we're creating these extra sessions that, okay, you just go at your own pace, just go over the recordings, the question, the notebooks, try ends on it. Then we come here, we do like a recap, and then we take questions based on those things that you've done. All right, so please try to follow the LMS and the past recording so that you can gain more from this program. Otherwise, if there are no other questions, we're going to call it a wrap at this point. So we'll meet again on Friday for the next session. So we'll be going right into the answer from the next class. All right, so just try to do some brush-ups at your end, and then we'll see on Friday. If you have any other questions, you can drop it on the group as well. We'll attend to it. Thank you all for joining today, and do enjoy the rest of your day. Have a great day.